Good morning, sir. My name is Koel. I am from DS2A. Today I am going to present our project based on simplified programming language called MiniATC. So MiniATC is a small educational programming language designed to understand the concept of automata theory, compiler design, lexical analyzer, and parsing in a simple and practical way instead of using complex programming. Only basic programming features so that we can easily understand how a compiler works internally. So MiniATC supports basic programming statements such as valid declaration, assignment statement, and print statements. Every MiniATC program must start with the keyword begin and end with end. So here are the contents what we are going to cover in this presentation. Aim and objectives, introduction, MiniATC language, what is lexical analysis and parser design, what are the tokens and rules, what are regular expression, and also we are going to construct the DFF for identifiers and numbers, and we are going to run the code based on the lexical analyzer and parser, and we will see the test cases and we will conclude with the conclusion. So here is the aim of the project. So the aim is of this project is to design and implement a lexical analyzer and parser for the MiniATC language using Python. So here we have used Python onto for coding. So the system checks whether the given ATC program is lexically correct, syntactically correct. So in both conditions are satisfied, the program is considered valid. So what is the objectives? So the objectives of our project are to understand compiler design concept, to identify tokens from the source program, to perform lexical analysis using regular expressions, to implement syntax analyzing using CFG rules. CFG means context free grammar, so which is only known as parser, and also to validate the MiniATC program to detect lexical and syntax error. Syntax error is nothing but CFG. So introduction of this project is compiler design is an important application of automata theory. Every programming language uses compiler phases to process source code. A compiler mainly works in different phases such as lexical analysis, syntax analysis, that is parsing, semantic analysis, code optimization, and code generations. In our project, we mainly focus on lexical analysis and syntax analysis, that is parsing. So the lexical analysis converts the source code into tokens, then the parser checks whether those tokens follows the grammar rules of MiniATC. So this project demonstrates how automata and grammar concepts are used in real programming language. So next, moving to the next is what is MiniATC language. As I explained before, so MiniATC language is a simple programming language which is used to which starts with begin and ends with end. All I have explained beforely. So what is lexical analysis? Lexical analysis is nothing but is the first phase of the compiler and is also known as scanning. In this phase, the source code is read character by character and divided into meaningful units called tokens. So example, x is equals to 10 semicolon. So here x is identifier, operator is equals to, and 10 is number, and that semicolon is dilemma. So this is the example. We will see that in next slides. So the lexical analysis performs several important tasks, that is, it identifies the tokens, removes unnecessary space, detects invalid symbols, classifies tokens into categories. The generated tokens are then passed to the parser for syntax checking that it is correct or not grammatically. Without lexical analysis, the parsers cannot understand the structure of the program. So here lexical analyzer plays a very important role. So what are the tokens and rules of this? Let's see in the next page. So tokens are the smallest meaningful units of a program. In MiniATC language, the tokens are classified into following categories. So here are the types of tokens, that is keyword, identifier, numbers, operator, delimiters. So what are keywords? Keywords are reserved words with predefined meaning like begin, end, int, print. All are keywords. So begin means it's the start of the program, end means it indicates the end of the program, int means it's a variable declaration, print means it display output. So what are the rules for this keyword token is keyword cannot be used as a variable name. They define the structure of the program. So next type of the tokens is identifier. So identifier are name used for variables. For example, x, total 1, sum 2. So these are the examples for identifiers. So what are the rules for identifiers? So must start with a letter, can contain letters and digits. Special symbols are not allowed here. For example, at x, these are not involved in or not accepted in identifiers. So as I told, there are valid case x comma value 1. It is a valid, but 1x comma a at b is not valid. It's an invalid case. So identifiers are used to store and access values in the program. So next one is the number. So number represents integer constants. For example, so here 10, 25, 100, all are the examples of numbers. So what are the rules? Rules is nothing. Rules are only here. Only the digits are allowed. Only non-negative integers are supported here. So numbers are mainly used in alignment, statements, and arithmetic expressions. So next one is operator. Operators are symbols used to perform operations. So here plus, minus, into, divided by, equals to all are operators. Example. So here equal to means assignment operator, plus means addition, minus means subtraction, into means multiplication, and slash means division. So the rules for this operators are used in assignment and arithmetic expressions. They must appear in proper syntax format. So next, the last type is the delimiters. So delimiters are the symbol used to separate statements. For example, semicolons, open brackets, close bracket. So these are the delimiters. So semicolon indicates the end of the statement, and the open and close brackets are used in print statements. So rules for this are every statement must end with semicolon. Parameters are used in print statements. So this is about tokens and their rules. So let's move to the regular expression. So what is regular expressions? Regular expressions are a pattern used to identify the tokens. So for example, identifier, that is A, Z, capital A, capital Z, and A here is that now. See, as you can see here, and for numbers is 0 to 1. For keyword begin, end, int, print. For operator this plus, for delimiters here. So all are this. So what are the identifiers? These are the first character must be in a letter. So it indicates that the first character must be in a letter. So next, remaining characters can be letters or digits. That's the meaning of this. So here the number this star indicates one or more digits we can have. So these expressions help the lexical analysis recognize valid patterns effectively, efficiently. So regular expressions are simplify the process of taken recognitions and are used in design finite automata for lexical analysis. So next is the next we will construct DFA for identifiers. So here we have designed a DFA for valid identifiers. Rules, what are the rules? First, we first character must be a letter, and the remaining character can be letters or digits, anything, as we have mentioned in previous page. So you see here invalid symbols are rejected. So how the working here is, start from initial state, that is q naught, checks first character, or if the first character is a letter, then it will accept and move to the accepting state if input is a letter. As I told, if the first input is letter, then it moves to the next state. If the input is not letter, then it will not move to the next state. So like that, after the first input is letter and the following inputs are digits, then it will accept. So like this, the transition diagram of the DF identifier is designed. So there is a transition table, that is if Q naught input is letter, then it will move to Q1, and if the digit is digit, then it will not move to any of the states. And similar to Q1, if the letter is if the input is letter, then it will move to Q1. If the input is digit, then it will also move to Q1. So there is the explanation of the transition diagram and transition table. So here is the valid and invalid cases, that is x some 1, total 2, 3, 1x, all are the valid and invalid. So similarly we have constructed for DFF for numbers. Here also the rules is only non-negative integers are allowed, must contain 0 to 9 only, at least one digits required. So here, so next transition diagram, same. If the first input is digit, then it will accept and move to the Q1 state. If other than digit, then it will not, means other than digits means if the negative, then it will reject. If non-negative, it will accept and move to the next state Q1, and similarly further also. So same the DFF number is designed same as the identifier. So next, what concept is context free grammar. What is context free grammar? Is used to identify the syntax of the MiniATC program. So it defines the syntax rule of MiniATC language. So it contains terminals, non-terminals, in start symbol, production rules. So here is the language for CFG. So a program here as I defined earlier only, that a program must start with, begin and ends with, and the statement can be repeated, supports delimit, declaration, assignment, and print expressions, allow basic arithmetic operations. All this I have mentioned previously. So what is parser design theory? A parser performs synthetic analysis. It receives tokens from the lexical analyzer and checks whether they follow CFG rules or not. Functions of parsers are validates program structure, checks statements, detects syntax error, accept or reject the program. If all the rules are satisfied, the parser declares and program has valid. Otherwise, the parser reports invalid. So this is all about the theoretical way. So next one is the implementation. So let's just run the code for this. So here's the implementation part. So here's the code for or the lexar and the parser. So here's the main py. So let's run this. So here after running the code, it will ask the options what we have want to do. So first we will choose one. So the lexical analysis mode will be chosen. Then we will enter the statement. So the statement will be begin int x next and. So here is a token for the lexical analysis, whatever the token keyword here, begin is keyword, int is also keyword, id is x, delimiters are semicolons, end is also a keyword. So similarly, if you want to check whether this is grammatically correct or not, then we will choose the parser, that is 2. Then similarly, we will put the code begin int x end. So it will say synthetically it is correct. So this is all about the program. So let's see the cases for this. So first we will opt one. Then we will first take the valid text case begin int x end. So this is a valid test case. So let's check for invalid. So this is an invalid and token that is a 9 var because it only accepts letters, not digits at first. So let's check for parser first valid case. It will come error. Let's check. Yeah, it is an invalid because here the begin spelling is wrong. So let's check for the valid case. So this is the valid case. So here the syntax is correct. So this is the valid case for both parser and lexical. So let me conclude this, that the lexical analysis identifies valid tokens such as keywords, identifies operators, and constraints from the source program, while the parser checks whether the token sequence follows the grammar rules of the language or not. Thank you.